Given an equation of a parabola where the vertex moves off the origin, graph the parabola using its focus, directrix, and vertex. Here's our equation. And we go for the vertex, and we see that h, which is on the x, is -4 because it currently is in the form of x plus 4, but that's x subtract -4. And of course the subtraction part is the h, because the form is x minus h. So h is -4. The other way to think of it is, what value makes x plus 4 0, and what value makes y minus 2 0. So you start at 0, 0, and that would be h is -4 and k is 2. So the vertex, -4, 2. Parabola opens which direction? Well, it's of this form. It has a square on the y part. It has a positive coefficient in there and a single x. So it's definitely left or right, but it's positive, so it's to the right. And find the p. The 4p has to be 12. 4p is 12, so p is 3. And now we just have to remember that the focus goes inside the parabola and the directrix goes outside. So first thing we do is mark off our vertex at -4, 2. So it's not at 0, 0 this time. It's at -4, 2. That's the vertex. And then from there, we're going to make a real light sketch of an opening to the right. So just like this. It's not the official curve yet, but it just indicates where we're going to put this directrix and the focus. The focus goes inside the parabola, and the p is 3. So 1, 2, 3, right there. So the focus is at -1, 2. Just by counting, not by doing any math there. And then the vertex is at -4, 2. Let's put that there. -4, 2. That's the vertex. And the directrix is 3 units on the other side. 1, 2, 3. So it's this line going through there like that. And that line is x equals, you can see, -7. So if you do have to add and do some math, it's just the x-coordinate adding on 3 and the x-coordinate of the vertex subtracting off 3, and that's how you get to these various values there. And now we're going to pick some kind of a point. We can erase our little temporary graph there and find some point on the parabola that's sort of equidistant from the focus and the directrix, somewhere around in here, like that. So it could be equidistant from the focus and the directrix, and that looks like about right. Okay, so now we're going to fit our parabola through there. So we drew that through the curve here, and we located another point on the other side here symmetrically. That was our little guess, and so that distance to the parabola equals that distance. Close enough. So there's our sketch of the parabola, and now we're going to compare it to the actual graph from the calculator and see how it looks. Now let's see how our calculator graph matches up here. So here's the original equation, and so we're going to take the square root of both sides, plus or minus. Going to add the 2 over to both sides, and so we have this, and because it's not a function, it's just a relation, we're going to have to graph it in here in 2 pieces. There is a way to do it in 1 piece, but that's called the parametric mode, and that's not part of the class. But for right now, this is the best we can do. And then we graph that, And here's our curve, and it looks pretty good. You know, it keeps on going like that. And that matches up pretty good with what we have over here. So, and it has the right vertex at -4, 2, so it's looking good.